Let's begin with this thing that is from really last time's set of notes. We did all the content, but we didn't fill in the table. What's the cosine of pi over 6? Right here, root 3 over 2. Is that what's actually on the next page? Okay, notice root, yeah, it is. Sine of pi over 6. Tangent pi over 6. Cosine pi over 3. Sine of pi over 3. Tangent pi over 3. People feel pretty good about that? That was just the content from last time, now we're filling it in. So, there are two takeaways for today. One of them is trig functions have some nice symmetries. And so we'll fill in this table exploring those symmetries. And we'll use those to complete, if you like, a lookup table for a bunch of values for trig functions. And that lookup table is the thing that goes under the name the unit circle, which I'd intended to have printed out or I'd hand back to you, but I don't, and that's on me. So it's not hard to draw. So let's draw a circle, namely this circle, and we'll fill in the entries we know. Here, space. That is an absolutely perfect circle. And let's fill in the entries that we already do know. And I'll focus on that first quadrant, but oh, you can't actually see what I drew. Sorry. I've drawn that much of a circle. So using those values we've already computed, if you rotate by an angle of 0, you'll be at some point cosine 0, sine 0. What's the cosine of 0? 1. Right, because that's the x-coordinate at this point. So I won't record this by saying sine and cosine. I'll just say that this point is the point 1, 0, and that will remind me that cosine of 0 is 1, sine of 0 is 0. Similarly, at this point, an angle of pi over 6 results in some xy value. X is cosine, y is sine. What's the cosine of pi over 6? Root 3 over 2. Sine? And from that you could compute tangent. Pi over 4. What's the cosine of pi over 4? Root 2 over 2. Sine? Root 2 over 2. Nice yawn. Pi over 3? 1/2. And what's the y coordinate? Root 3 over 2. And at an angle of pi over 2, what is the x and y value? 0, 1. You don't really even have to think hard about what trigonometry means to know that. So those are the angles that we just know in quadrant 1. And ideally, I'd have that picture to hand out to you so you'd have all the quadrants. What I'm going to do is use some symmetries of the unit circle to fill in some entries in the other quadrants. And as we fill those in, we'll also get neat formulas that trig functions satisfy. That seems like a plan? Nice. So I'll be flipping back to this page an awful lot. Here are the formulas that I'm going to complete. I'm going to figure out what these values are. And we'll do it by just thinking about them one at a time. So first, let's think about what happens if instead of evaluating trig functions at some input theta, you add a multiple of 2 pi to that angle theta. Let's just think about what that means. If k is an integer, then what sort of angle is 2 pi times k? What angle is 2 pi? 360 degrees, one full revolution. It's all the way around the solid. So let's think of it comes that. So that 2 pi k radians is k full revolutions. So if you want to think about a rotation by theta plus 2 pi k, you can think of it by first rotating by k full revolutions, and then rotating by an angle of theta. So instead of rotating by, so that means, what's the instruction? Start at 1, 0, go around the circle a bunch of times, now rotate by some amount. Do those full revolutions affect the xy value you land on? No. So it's the same as just rotating by an angle of theta. So similarly, those 2 pi k's don't affect sine and cosine. Cosine of theta plus 2 pi k is the same as cosine of theta. Sine of theta plus 2 pi k is the same as sine of theta. So can I do the same thing for all the other trig functions? Yeah, nice. So, if someone hands you an angle that's bigger than 2 pi, you can say, well, screw it, I don't want to think about an angle bigger than 2 pi. You can subtract off any excess 2 pi's, and hopefully get an angle that's easier to work with. So, that idea makes sense to everyone? Cool. So, next let's think about what happens when instead we go by negative theta. And I put that 2 pi minus just to be, reasonably helpful, because right, 2 pi minus theta means go around by 2 pi and then back by theta, or just back by theta, same thing. Let's try to figure out what those trig functions are. And we'll do it by drawing a picture. So there's a circle. Here's the result of rotating forward by an angle of theta. So I'll have that here in purple as well. And here's what happens if you rotate backwards by theta. Those two lines, is there like some symmetry of the plane that relates them? If you wanted to get the orange line, you would take the purple line and do what to it? I guess let me do the purple one.
Reflect.
Yeah, reflect over. Yeah, awesome. So what relation relates these pictures? Orange equals purple after reflecting over the x-axis. So just keep that in mind. So if you want to think about an angle of negative theta, you can instead think about an angle of theta, but then reflect over the x-axis. And we'll get a fact out of that observation right here. Reflection over the x-axis, what does that do to x-coordinates? I guess maybe it's useful to have the picture back up. So I'll put back to the picture. You can stay on that page. So if I want to think about trig functions, I want the xy value of those points. Those two green points, how do their x coordinates compare? They're the same. How do their y coordinates compare?
Different.
They're different, but like in a very specific way. They just have, one's negative, the other. So how does this reflection change xy coordinates? The x coordinate is preserved. Yes. The y coordinate is negated, made negative. Nice. So that let us compute some trig functions. So cosine of negative theta, so that's like a circle. There's negative theta. There's theta. So if I want to think about cosine of negative theta, I want the x-coordinate at the end of the green line. So that's like the new x-coordinate. What's that in terms of the x-coordinate at the end of the purple line? It's the exact same?
X.
Yeah, it's whatever that x value is. Maybe I'll call them x old and x new for the new point and the old point. But the x-coordinate of the original point, what's that in terms of a trig function? Which trig function gives you the x-coordinate? Cosine. Here's the payoff. Cosine of negative theta is equal to the cosine of theta. Let's do the same for sine. Sine of negative theta, or sine of 2 pi minus theta, that's the new y-coordinate. What's the new y-coordinate in terms of the old y-coordinate? And which trig function gives you a y-coordinate? So this will be negative sine theta. Nice. So there's a fact. Instead of thinking about sine of negative theta, you can instead think about negative sine theta. And I'm just putting that on that cover page. And as long as we're here, we have a name for that sort of behavior. So it looks like cosine is a function in which, when you make the input negative, the output doesn't vary. What type of function is that? What's the word for that type of function? Yeah, that's an even function. Even functions are functions that don't care if there's a negative sign inside the parentheses. What type of function is sine? Odd. Yeah. Odd functions are functions where you can take the negative sign from the inside of the parentheses or from outside the parentheses. Cool. So maybe right here. So sine of theta is odd. Cosine theta is even. Groovy. Let's use that to actually do something. All right. So cosine negative theta is the same as cosine of theta. Sine of negative theta is negative sine theta. I'll fill in the next couple lines in just a moment. But let's use this first to get some unit circle information. So, (11 pi over 6). That's the same as 2 pi minus pi over 6. That must mean this point is the exact same as that point, but reflected over the x-axis. So what are the coordinates of this point? This point? This point? I guess we already knew this point, but what's this point? Cool. So, using only this fact that 2 pi minus an angle gives you the same cosine and sines that are different by a negative sign, we've just doubled the information that we got last time. That feel pretty good? Let's do some more stuff with this. So here's a fact that I won't justify for quite a while. The cosine of pi over 8 is the square root of 2 plus the square root of 2 all over 2. Using that information, do you think we can compute these two things? Let's try to do it. Maybe we'll do this one first. Does cosine care if there's a negative sign inside the parentheses? No, it's even. That's what we just got. So cosine of negative pi over 8 is the same as cosine of pi over 8. Do we already know what the cosine of pi over 8 is? I guess as long as you believe what's written at the middle of the page. I haven't told you why that should be true. It is. So what's the payoff? If someone tells you something about a trig function, they've really told you something about a trig function at many other inputs because of these symmetry properties. Same thing here. Do you think we can compute the cosine of 17 pi over 8? Yeah, 17 pi over 8 is the same as 2 pi and then go back by pi over 8. Right, because 2 pi is... No, wait, I'm trying to trick you here. So let's think about what 17 pi is. That's the same thing as the cosine of. So it only has something to do with pi over 8. Pi over 8. And something to do with 2 pi. What symbol should I put between those two things? If I want to get 17 pi over 8? Let's try something that'll just be wrong, and then we'll see what should be right. So I have an erasable pen, so I'm not worried about being wrong. Let's suppose you think maybe it should be minus. Let's see if that's actually true. So maybe I'll do this off to the side. 2 pi minus pi over 8. Let's try to compute that. Oh, you can't see what I just wrote. I should just zoom out a little bit. It's going to be too hard. 2 pi minus pi over 8. Looks like there's a common denominator there of divide by 8. So how should I rewrite 2 pi to do fraction addition easily? (16 pi over 8 is how I should write 2 pi. All right, those fractions are now easy to write. So it looks like that is equal to 15 pi over 8. Is that what's inside of those parentheses, though? No. So what should I change about that to get 17 pi over 8? Yes, I should put a plus there. All right, so this is the same as cosine of 2 pi plus pi over 8. Does cosine care if you add 2 pi to the angle? None of the trig functions do, so you can erase this extra 2 pi plus. Is that something that we know what it is? Groovy. As we've done before, if you know cosine of an angle, you can figure out sine of that angle by playing this Pythagorean identity game. Maybe I'll pause and say, if you do it, you'll get sine of pi over 8 to be this. Should we do it? If you're interested in seeing the Pythagorean identity thing being done right now? Okay. So you know how hands actually go up. There's the sine of pi over 8. Let's use this to do some computations. Let's try to compute the sine of 15 pi over 8. So 15 pi over 8 is close to 2 pi. In fact, well, how would you rewrite 15 pi over 8 in order to see a pi over 8 showing up?
2 pi minus pi over 8.
2 pi minus pi over 8, because we actually just did that, didn't we? Sine of 2 pi minus pi over 8. All right, what happens to sine when you replace an angle by 2 pi minus that angle?
Negative.
It becomes negative. Right, the 2 pi itself doesn't matter, but sine is odd. So maybe all of the intermediate steps would be, well, first you would just drop the 2 pi. So now it's sine of negative pi over 8 is negative sine pi over 8. Do I already know what sine of pi over 8 is? Yeah, so I'll just plug that in. Apparently I stick with that negative sign. Cool. That feel pretty good? Oh, yeah, sorry. How about sine of negative pi over 8? What's that equal to?
Same thing we just did.
Yeah, the exact same thing? Cool. People feel pretty good? Nice. So let's go through the other entries in that table. So the next thing in the list, I'm going to flip back and then flip forward, is what happens if instead of thinking about an angle theta, you think about pi minus that angle theta. Let's try to draw a picture of that. So here's the result of rotating by an angle of theta. Let's try to draw an angle of pi minus theta. Let's see. Let's try to do it. How big an angle is theta? How much of a revolution is an angle of pi? Sorry, I said theta, but I meant pi. What sort of angle is pi? It's 1/8, so it's like, if you start there, there's an angle of pi. So this is saying rotate forward by pi, and then go back by theta. So let's draw that. I think I'm going to want this picture to be nice and clean, so I'll draw a vaguely scratchy picture here. So go forward by an angle of pi. Now I go backwards by an angle of theta. So if there's my angle theta, here is the angle of pi minus theta. And now that we have this picture, how do the xy coordinates of the pink line and the green line compare? Well, I guess first, what reflection relates them?
Y-axis.
Reflection over the y-axis? That seems right. The reflection which takes x values and makes them negative. These are related by reflection over the y-axis. So the x-coordinate becomes negative. The y-coordinate stays the same. Nice. So, let's do that. So cosine of pi minus theta, that's the x-coordinate after you do this reflection. What is that x-coordinate in terms of the original x-coordinate? It's negative what it used to be. And what is the trig function that gives you the old x-coordinate? All right, now let's do sine. So sine is the y-coordinate. So how did the y-coordinate change under this reflection? Stays the same. So which trig function does that give? Nice. All right. So I'm going to do a little bit of backtracking now. I'm going to go back to the cover page and write in those formulas. So cosine of pi minus theta is negative cosine theta. Sine of pi minus theta is the same as the sine of theta. Does that feel pretty okay? Nice. So the other bit of backtracking I'm going to do is I'm going to flip to the next page. So, this page, it's a page that's labeled 135. Because I noticed that I didn't do some stuff. Which no one stopped me, so. So let's try to figure out what secant, cosecant, tangent, and cotangent are. And let's do it by doing this. Let's not try to be sneaky about drawing a diagram. Let's just do algebra and use that we know what sine and cosine do. So maybe the strategy I'll follow is I'll talk through secant and I'll talk through tangent, and then maybe I'll pause for a bit and you'll tell me what happens for secant and cotangent. So let's do it. So I want to compute the secant of negative theta. What's the secant in terms of sine and cosine? One over cosine, but there was a question mark at the end of that. So maybe it would be appropriate for me to take some more board space and just to remind everyone what tangent, secant, cotangent, cosecant are in terms of sine and cosine. And this podium is a tragedy. So secant is 1 over cosine. Cosecant is? Very good. Tangent is? Sine over cosine. Cotangent is? Cosine over sine. How many people think that they might put this sort of stuff on a note card for maybe that upcoming quiz and then eventually a midterm? Yeah, I mean, I bet by the time the midterm rolls around, you'll have these bonded into your brain anyway, but it doesn't take up much space. Was that also a question, or were you just agreeing?
I was just agreeing.
Ah, very good. Very good. So let's use this down here. So secant is apparently 1 over cosine. So secant of negative theta is 1 over the cosine of negative theta. All right, well, I know what to do with the cosine of negative theta. Does cosine care whether there's a negative sign inside the parentheses? So this is the same as 1 over cosine theta. And what's another word for the cosine of theta?
X.
Sorry, what's another word for 1 over the cosine of theta in terms of these symbols?
Secant.
Yeah, it's the secant. Cosine is the x-coordinate, that's true. Nice. So it looks like secant negative theta is the same as the secant of theta. Let's do tangent as well. And I'm eating up my margin space. Tangent of negative theta. Let's try to compute that. So what is tangent in terms of sine and cosine? Sine over cosine. So this will be sine of negative theta over cosine of negative theta. Do I know what to do with sine of negative theta and cosine of negative theta? Yeah, what's the sine of negative theta? Perfect. Cosine negative theta becomes? Cosine theta. All right, so I see negative sine theta over cosine theta. What is that in terms of those functions? Negative tangent. So apparently tangent is odd. Does it feel pretty okay? So my intent with this lecture is to have it take multiple days, so I'm okay with spending some more time. So I want to pause for a moment. This half of the class, well, half is the long one. This part of the classroom will compute cosecant negative theta. You four will compute the cotangent of negative theta. the type who has already filled in the entries a while ago. If you just want an opportunity to have someone stare at it right now, this is okay. People here coming together. Cosecant of negative theta is
Negative cosine.
your negative cosecant of theta. Does that agree with everyone? Any different answers? Yeah, that's fine. Right, you wind up with a negative sign in the denominator. Right, like 1 over negative 5 is the same thing as negative of theta. All right, cotangent negative theta is?
Negative cotangent.
And you're a negative cotangent. So here's the main point of this exercise. On the one hand, you could like just write down all those formulas and bond them into your brain and put them into your note card too. Do you think that's worthwhile if it took so little time to reinvent them on the spot? Yeah, so eventually, if you just use them enough, they'll find their way into your memory. But in the short term, just remember that cotangent is cosine over sine. If you know something about cosine and sine, you can figure out something about cotangent. Cool. So let's do something very similar now. Or maybe I'll see if people want this similar thing. So I know that the cosine of pi minus theta is negative cosine theta. I know that the sine of pi minus theta is the sine of theta. So do you think we could do the same thing for secant, cosecant, tangent, and cotangent? So the two plans I can think of from here is I can just write things down. Or we can take some time and go through one of these same computations. People want to spend class time doing that same thing again? All right. I will write down the result. Maybe I'll talk through it very quickly. So let's see, secant is 1 over cosine. I know that cosine will become negative. 1 over a negative is just that negative. Feel pretty good? Groovy. Tangent is cosine over sine, sine over cosine. So let's see, it'll become sine over negative cosine. I only see a negative in the denominator. So what's going to wind up going in that blank? Nice. Cosecant, similarly, will just become cosecant. Cotangent, pi minus theta, will become negative cotangent theta. That seem pretty okay? So there's what happens when you subtract an angle from pi. The next thing in the list is what happens when you add an angle to pi. So we start at 0, we rotate over to get to an angle of pi, and then we rotate a little bit more. So drawing the picture, there's rotation by an angle of theta. If you want to rotate by an angle of pi plus theta, we'll first rotate by an angle of pi, and then by an angle of theta. And I guess, same question. what symmetry relates those two angles?
Over the origin?
Yeah, reflection over the origin. All right, that makes sense. The two things that are opposite over the origin differ by like 180 degrees. Rotation by 180 degrees about the origin. 180 degrees is pi radians. These are related by reflection over the origin. And now we'll just write down how that changes x coordinates, y coordinates. What does it do to coordinates?
Makes them both negative.
Makes them negative. Well, maybe the pedant in me doesn't like the answer of it makes them negative. If they already were negative, they would become positive. But like, you mean the right thing. It multiplies them by -1. So let's go through the motions. So cosine of pi plus theta is the new x coordinate. You just told me that's the same thing as negative the old x coordinate. So it'll be negative. What is the x coordinate in terms of sine and cosine? So cosine of pi plus theta is negative cosine of theta. Sine of pi plus theta, well, jump right to the end. What should sine of pi plus theta be?
Negative.
Negative sine theta? People buy that? Cool. Ah, you couldn't see what I was writing, but you know what I wrote. So, going back to the first page where there's that table of formulas, cosine of pi plus theta becomes negative cosine theta. Sine of pi plus theta becomes negative sine theta. So, secant and cosecant, maybe you already know what will happen, so let's just write that down. There's not much novel there. Let's go through what happens for tangent, because it's at least a little bit different from previous situations. So let's try to compute tangent of pi plus theta. And we'll do it by following the exact same steps. Tangent is what in terms of sine and cosine? Sine over cosine? So this will be sine of pi plus theta divided by cosine of pi plus theta. What happens to sine when I replace theta with pi plus theta? It becomes negative, what it used to be. So negative sine theta. Same thing, but with cosine. Cool. Do you see anything that simplifies? Yeah, dividing and multiplying by a negative, negative divided by a negative will become positive. So I just get sine theta over cosine theta, which is back to tangent. So it looks like tangent has the property that it doesn't care if you add an extra theta to an angle. And cotangent will do the same for the exact same reason. But maybe let's come back to this and think of it in terms of like the geometry also. So tangent is supposed to be the slope of a line, right? So if you want tangent theta, you rotate forward by theta, and then you just recover the slope. All right, remember saying that? So pi plus theta is going to give us this angle. Do the pink line and the black line in that picture have the exact same slope? Yeah. Right, if you like, delta x has become negative and delta y has become negative. So yeah, the tangent should be resolved because tangent is the slope. There's another geometric way of seeing the same thing. People feel pretty good? Nice. So let's use these facts. I'm going to go back to the unit circle here, and I'm going to fill in some entries. Or maybe I should do this on the paper, like the place where I actually drew the thing. Maybe that's the obvious thing to do for note records. So we have a few entries already. Now, yes, now we did it this way. 11 pi over 6, 7 pi over 4, 5 pi over 3. These corresponded to the points. Root 3 over 2, negative 1/2, negative root 2 over 2, root 2 over 2. No. There. 1/2 by negative root 3 over 2. Zero, negative 1. So we also have what happens if you rotate forward by theta and then go back. So this pi over 6 is going to correspond. So if we do that, we go forward by pi, back by pi over 6. That will put us at 5 pi over 6. So we know what an angle of 5 pi over 6 should correspond to. See, it'll be exactly the same as that point, but the x-coordinate will be negative. So, trig functions of 5 pi over 6. You can compute by knowing that cosine is negative root 3 over 2 by 1 over 2. Pi over 4, if I go forward by pi, back by pi over 4, that'll put me at 3 pi over 4. Negative root 2 over 2 by root 2 over 2. And finally, if I go forward by pi, back by pi over 3, I'll be at 2 pi over 3. Negative 1/2 root 3 over 2. Does that feel pretty okay? Legibility is kind of crap, but I guess another point is, it looks like you don't actually need to remember what's in this quadrant. It's exactly the same as in this quadrant, but the x-coordinate is negative. I think we can figure out what goes down here as well. So 7 pi over 6, what should be if the xy coordinates that correspond to that angle?
Negative square root of 3 over 2.
Yeah. That point, but negative? 5 pi over 4 will be
Negative root 2 over 2.
that, but negative. And the next one?
The next one.
Cool. Those ideas seem useful? Nice. So what I do intend to have for you on Monday is like an actual clean printed unit circle for those things to have been drawn on. So now let's play this pi over 8 game again. Let's use the knowledge about trig functions of pi over 8. So what we wrote earlier, cosine of pi over 8 is the square root of 2 plus root 2 over 2. Sine of pi over 8 is the square root of 2 minus square root 2 all over 2. Let's compute some other trig functions using them. So we can understand an angle of 7 pi over 8. And that's the same as starting at 0, going forward by pi, and backward by pi over 8. So that's the same as cosine of pi minus pi over 8. What does cosine do when you put pi minus a thing inside of it?
Negative.
It becomes negative. Yeah. that false one. So you can always draw a picture to help you with this. That's why I gave you the derivations of these. Right, this says go forward by pi and then backwards by a little bit. So cosine as the x coordinate becomes negative. So this will be the same as negative the cosine of pi over 8. And do we know what the cosine of pi over 8 is? Yeah. It's that. Negative the square root of 2 plus the square root of 2 all over 2. With 5 minutes left, I think my intent will be I'll do one of these 3, and then I'll split you up to do the remaining ones, or we can move on. So let's do one more. We'll do one more and go. Which one of 2, 3, and 4 would you like to see me do? 2? 3? 4? Alright, I think the 3's happen. So let's try to compute the cosine of 9 pi over 8. So to understand 9 pi over 8, well that's pi, and then next to pi over 8. So drawing the picture, go forward by pi, and then go a little bit further. So it looks like that's the thing that corresponds to a flexion over the origin. So what does cosine do when you do pi plus an angle? Becomes negative, I think? Yeah. Negative cosine pi over 8. Oh, but I know what that is already. Cool. That idea seemed natural enough? Let's try to get a start in on the next result. So here's an angle, what happens when you change. So the next thing in the list is what is the cosine of pi over 2 minus theta? So let's try to figure that out. What sort of angle is pi over 2?
90.
It's a 90-degree angle. It's a right angle. So if there's an angle of theta, to figure out an angle of pi over 2 minus theta, it'll be a right angle, and then you get to go back by an angle of theta. So just by looking at that diagram, what symmetry relates those two lines? Or what symmetry of the plane? How does one of those lines go to the other?
Reflected over the,
I don't know what Z is. They're saying reflection over this dashed line, right? How about the line y equals x?
yes.
That is it, right?
Yes.
It doesn't need a fancy name. So apparently this is, so there's the line y equals x. These are given by reflection over the line y equals x. And what does that reflection do to xy coordinates? I think, well, it definitely does something, because those 2 points aren't the same. So it does something. Yeah, x's become y's, y's become x's. Remember this from the lecture on like inverse functions? Yeah. X's become y's. Y's become x's. I have enough time to finish this thought. So let's write down what cosine and sine become. Then we'll carry this on after the weekend. So cosine of pi over 2 minus theta, that's the new x coordinate. But what does the new x coordinate correspond? How does that relate to the old x and y coordinates? It's y. And what trig function gives you y? Same thing but for sine. Cool. So I'll flip back to that first page to fill in that entry. So sine and cosine have the property that if you replace an angle by pi over 2 minus theta, cosine becomes sine, sine becomes cosine. And as people pack up, maybe I'll just say a few words about the homework associated with this lecture. So this lecture is going to be split over 2 days. So the deadline is set as though it's assigned this coming Monday. So it's due a week from Monday. And it includes, and we'll spend some time in class on these computations. So suppose I tell you cosine of some angle and what quadrant it lives in. That's enough information to figure out sine. Once you know sine and cosine, you know what all of these operations do to angles, so you can figure those out. These four take a little bit of effort, but not that much. Then the bottom two are easier going. So, I bet you have everything you need to figure out those right now, even though we haven't covered all the content. Yeah. Nice. How did you get it, everyone?